Hey, welcome back. This is chemistry question 45 from IMAT 2022 past paper. So I will be explaining how to solve this question. So it says which of the following separation techniques can be used to obtain liquid ethanol from an aqueous mixture of ethanol and ethanoic acid. So we have three lists of these separation techniques: filtration, fractional distillation, and centrifugation. Okay, and our main objective is to obtain a pure ethanol from this mixture of ethanol and ethanoic acid. Okay, so first of all, we must know that this aqueous mixture of ethanol, and ethanoic acid is an homogeneous mixture. Homogeneous mixture. So why is that? Because we know that all of these compounds, including water, are all polar molecules. So they are highly miscible and therefore they dissolve very well and mix also. So they appear all in same single phase, which means they all appear in a liquid phase as single phase. Everything over here is liquid, so this is single phase, and therefore it's a homogeneous mixture. So we have identified it, the type of mixtures it is. Okay, so and we must know the boiling point for each of these compounds. So I'm going to arrange in order from increase in boiling point, the order. Okay, so the first one is going to be the least boiling point, which is ethanol, ethanol, and then the second one is ethanol, and then third one is water molecule, and then the fourth one is ethanoic acid. Okay, so the reason for this is because ethanol, so the basic structure I'm going to draw here, the basic. So the ethanol is an aldehyde and its chemical structure is this. So R stands for carbon chain behind. Okay, so carbon and hydrogen only. And then R, and then this is for ethanol. Okay, so this is structure for ethanol, the alcohol, because it's an alcohol. And water molecule, that's easy. You know, it's an H2O. And ethanoic acid, the simple structure I'm going to draw over here. Sorry. Okay, so this is structure for ethanoic acid. Okay, so now I've drawn the basic general structure for each of these compounds. So now I'm going to write down the type of bonding these compounds typically form. So we know ethanol, the reason it has the least boiling point over here is because it primarily forms dipole-dipole interaction. Dipole-dipole. So these are intermolecular forces, which are weak interactions between these compounds, which is of basically a physical interaction, not like chemical reaction. Okay, so these are weak interaction between these compounds. Okay, so it's a dipole-dipole, but since we know it's an aqueous mixture, so it does form a hydrogen bonds with water. So we know water has hydrogen attached to a highly electronegative atom, which is oxygen. Okay, so this can form hydrogen bond to the highly electronegative atom on ethanol, which is this oxygen, carbon double bond to oxygen. So this is how it forms. So basically, this is hydrogen bonds and forming this water molecule. Okay, and it forms only a single hydrogen bonds. Okay, so therefore it has the least boiling point. It does form H bonds as well, but it cannot form hydrogen bond with other ethanol molecule. It only forms dipole-dipole interaction. But if there's water and other compounds that has hydrogen attached to a highly electronegative atom, which can be nitrogen, fluorine, and oxygen, like water molecule, ethanol, and ethanoic acid, it can form hydrogen bond. Okay, so These are two types of bond, but hydrogen bonds is only formed only if these molecules are available. Since we have aqueous mixture, so it can form hydrogen bond. But if it was a pure liquid of ethanol, it only forms dipole-dipole interaction with other ethanol molecules. Okay, now ethanol, it also forms dipole-dipole interaction, and also it forms hydrogen bond with both water molecules and other compounds that has hydrogen with highly electronegative atom, and also with other ethanol molecules because it has hydrogen directly attached to this highly electronegative atom. Okay, and the water molecule also indeed forms dipole in this aqueous mixture and attach hydrogen bonds, and same for carboxylic acid, dipole and hydrogen bonds. And why does ethanoic acid has the highest boiling point is because it can form two hydrogen bonds easily. So this is how it is. With other carboxylic acid, the ethanoic acid, it can easily form in this way. It can also form a dimer. This structure is known as dimer. Okay, so like this can easily form two hydrogen bond, forming a stable structure which we call as dimer. And that's what has highest boiling point in this given mixture. Okay, and the most important point I missed is that all of these compounds also form the weakest interaction, which we call as LDF, because LDF is common in almost every type of molecules. It can form between non-polar molecules as well. But in this case, where everything is polar molecules, so I'm only focusing on dipole-dipole and hydrogen bonds. Okay, but LDF is common, so it's not necessary I have to mention in this question. Okay, so these are the major interaction form, but we know ethanoic acid forms a dimer, which is a stable structure and also forms the most hydrogen bonds. But ethanol is the weak over here, having lowest boiling point because it only forms one hydrogen bond, and it does also form dipole-dipole interaction. Okay, so that's the four four of these molecules. It's interactions that are formed. Okay, so now what we can do is now we can compare in each of these separation techniques and identify which one is the most suitable. Okay, so first of all, the option one is filtration. So we can easily cross this out, and it's wrong because filtration are primarily used for heterogeneous mixture. Heterogeneous mixture. So heterogeneous mixture, as I explained, for a homogeneous mixture, is complete opposite of that. It's a mixture where both are at different phase. Okay, so they're not at single phase, they're different. So filtration, like for example, you have sand in water, so you can easily use filtration to filter out to obtain pure water. But in this case, we have homogeneous mixture. Okay, everything is in liquid phase, and filtration cannot separate this ethanol from this mixture because everything is in single phase. So filtration is wrong. It's for heterogeneous mixture. Fractional distillation is correct because fractional distillation uh, obtains ethanol based on its boiling point. They separate the mixture based on their boiling points. So this is highly specialized for homogeneous mixture to separate certain molecules or substances based on its boiling point. Homogeneous mixture. Okay, so fractional distillation is a correct answer, and centrifugation is wrong because centrifugation is also used for heterogeneous mixture. So the common example where centrifugation is mainly used is like, for example, a blood sample. So we know a blood is actually heterogeneous because it has many uh, insoluble compounds like fibrins and platelets, which are involved in blood clotting. So these are insoluble. And we also have red blood cells, white blood cells, and we have plasma. So all of these are in different phase. Okay. But although they are mixed in a way that we can't see with our own eyes. But if we use centrifugation, it will form like layers. Like for example, this is a test tube and we have blood over here, so it will form a separate layers. Okay, so this one being the plasma and then red blood cell, and we have platelets, the heaviest one. This is if you use centrifugation for the blood. Okay, so this option is wrong. So the only correct option is option 2, fractional distillation. So option A is correct. Okay, so that's how we solve this question. I hope you find it helpful. Thank you guys for watching my video. Please leave a like and subscribe to my channel. Thank you guys. Bye.